Hello. In our previous lecture, we have discussed about SSH protocol, which is a secure shell protocol. It's an application layer security protocol. And today we are going to discuss about secure socket layer or transport layer security protocols, which is often called as SSL or TLS protocol. Earlier, it was called SSL or secure socket layer, and the recent ones are TLS or the transport layer security protocols. So this is actually uh, a, a bunch of cryptographic algorithm, a protocol suite. This is called protocol suite, a bunch of cryptographic algorithms, several cryptographic algorithms for different purposes. Not only like, for example, for signature schemes, this SSL TLS protocol suite comes with RSA, DSA, and elliptic curve DSA, like that sort of a bunch. So then the users have the flexibility to choose whatever the uh, signature scheme to be used in that particular application. For data encryption as a block cipher, this is coming as 3DES and AES. So the user has the flexibility to use either 3DES or AES. So this is not a single protocol, this is a combination or a bunch of uh, cryptographic algorithms, implemented cryptographic algorithms. So this is often considered as an application layer security protocol, but this actually lays between the application and transport layer. So all the application, the web information, particularly web information, which is running in the application layer, it is going through this protocol suite, this security protocol suite, and go to the transport layer, the TLS layer. And in the TLS layer, the packaging has been done. So these are some information about this SSL TLS protocol suite. It is called a secure socket layer, proposed by Netscape. SSL version 2 is released in 1995 and SSL version 3 released in 1996. Then TLS or the Transport Layer Security Protocol suite came after that. So TLS version 1, which is equivalent to the SSL version 3, which is in 1999, and after that TLS version 1.1, 1.2, and 1.3 are released. Now this 1.3 is also released. So when we have the TCP/IP protocol layers like this, we have application layer. There we have the web applications, file transfer, or secure login, or uh, any application. And then we have the transport layer, the TCP layer. There the packaging is done, that packet processing, and then the internet layer addressing, and the network layer is finally, and then data is sent to the channel. When we have that TLS SSL protocol suite, we can see in here in the red color, it is uh, in between application and transport layer. So application layer data is transferred through this security protocol suite, this security layer, and then necessary encryption and hashing, signature generations, whatever the security precautions are done, and data is transferred to this the TCP layer. Then after that, on top of that secure data, the packaging is done, and then addressing is done and sent to the uh, channel as a protected packet of data. Okay, so these are some information about SSL and TLS. This transport layer security, nowadays it is called a TLS, not SSL. Older name is SSL, and is a cryptographic protocol that operates at the transport layer, actually above the transport layer, and below the application layer. So this uses encryption and public key infrastructure. We have discussed mildly about public key infrastructure in our public key cryptography lectures. Today I'm going to uh, talk a little further about public key infrastructure as well. uh, Uses encryption and public infrastructure to provide protection for network communication protocols operating at higher levels. For example, to protect HTTP communication, that is Hypertext Transfer Protocol, the web information, HTTP protocol sends and receives the data for your websites showing in your web browser. So to protect this kind of application, the web applications, we have to protect this, we have this the security protocol layer, and then you can see it is called HTTPS, secure HTTP is there to protect your data, and it uses X509 certificates to obtain public keys. So you can search about this X509 standard, about public key and certificate standard. I'm not going to talk details about that, but I'm going to show you uh, some information and how the certificate is organized. And this can be used to provide confidentiality and authentication. Obviously, when we have cryptographic algorithms, the responsibility of cryptographic algorithms is to provide confidentiality and authentication. And this diagram shows again uh, how the encryption and authentication layer added to the protocol stack between the TC, the transport layer and the application layer. So in the previous diagram also you have seen that. So this security protocol suite, or that bunch of protocols, is layered in between the transport layer and the application layer. And this diagram shows that application data is going through the protocol suite to the TCP layer and the IP layer, and then through the channel it is sent to the public internet, and through the internet uh, the data is sent to the required destination. Okay, so when we have this TLS protocol suite, we say we have two main operations there: TLS handshake operation and record layer operation. Or there are two layers: handshake layer and the record layer. So what's the handshake layer? So when we have a connection between the client and the server, first the client and server communicates with each other to establish a secure channel. This secure channel then provides the facilitate to secure transmission of web information, the whatever the data in the website. So this handshake protocol is the kind of transmission, the communication between client and server to establish a secure channel. So this is completely exchanging the uh, exchanging a key between client and the server. So there are three things done at this stage. The first thing is client and server negotiate the cryptographic algorithms to be used. So that means I said this TLS SSL protocol suite comes with a bunch of cryptographic algorithms. So for digital signature, there are several algorithms. Uh, for hashing, there are several algorithms, and for block ciphering, the uh, encryption, symmetric key block ciphers, there are several algorithms like 3DES, AES, likewise. And for public key cryptography, there can be different number of algorithms, few algorithms. So first, at this this point, to negotiate the public key, negotiate the cryptographic algorithms, client and server discuss, okay, for signature generation, signature sign-in, we should use this algorithm. They choose one algorithm for signing. They choose another algorithm for block ciphering. So there are, I said there can be many algorithms for block ciphering like 3DES, DES, and AES. So among them, they agree that we will use AES algorithm for this. And for signatures, there may be few algorithms like RSA signature and digital signature DSA and elliptic curve digital signature ECDSA. So among them, client and server agree to use RSA for encryption, or RSA for signing, or DSA for signing. Likewise, they negotiate the cryptographic algorithms to be used, and then they authenticate each other. So client says, I am this client. So usually the authentication is client is not going to authenticate to the server, but server is going to authenticate to the client. So server is the actually the entity that delivers the information to the client when client requests. So server has to authenticate who he is, and then after that authentication, they both establish an encryption key for symmetric key encryption, because symmetric key encryption is faster than public key encryption. Because of that, they establish a symmetric key between them to use symmetric encryption schemes for their data transmission. So after that, in the record layer, the data transmission is done. So in the handshake layer, we can see they are negotiating and authenticating each other, and then establishing a symmetric key. After that point, data transmission is done using a faster uh, encryption algorithm for make the data protected in the channel. So that's the very high level idea about this the HTTP and TLS, how this TLS is used for HTTP communication, the web communication. So in there, you can see in this diagram, you can see when we have the message authentication code is generated uh, to ensure the integrity and do the encryption to provide the confidentiality, and the encrypted message uh, is sent through the internet. So because this is encrypted message, confidentiality is ensured, and this message authentication code tag, MAC tag, provides the integrity for this message. So we can consider this is going through a secure channel or secure pipe. Nobody can see the content of the message. Nobody can alter the message. Nobody can uh, change the content of the message or read the content of the message. It's like through the internet, this is going uh, through a secure pipeline. That's why this tube like thing is drawn, meaning that it is not possible for outsiders to read or alter the message because of this confidentiality and integrity achieved by MAC and encryption. Okay, so in this kind of communication, certificates plays a crucial role. So certificate which is coming with the public key infrastructure, PKI. A certificate is an assertion by a trusted third party that a particular public key belongs to a particular entity. So when we have this kind of communication, you can see when client negotiate with a server about cryptographic algorithms to be used, and then client has to authenticate the server. I am actually this person. And then server has to, especially the special thing is the server has to authenticate the client that actually I am the server. I am the server that you are looking for. So for that purpose, server shows the certificate he got from a trusted third party. Client initially doesn't trust this server, but client trusts the trusted third party. Because of that trust, client will trust this server because the server's certificate is signed by a trusted third party. How does this client trust that trusted third party? So trusted third party's information is embedded to the client. So that can be like we can manually do that, or uh, operating systems provide that information by default. So somehow that trusted third party's public key is provided to the client. Client can manually take that public key and install it in the computer, or operating systems do that. Somehow that information is with the client, and because of that, client can verify anything signed by the trusted third party. So the server certificate is signed by the trusted third party. Because of that, client is going to trust this server once this server shows the certificate. And from that point onward, client can get the public key of that server, because it is that information is given in the server's certificate. And now that client trusts the server's certificate, and from that point onward, client will trust the public key of the client, and client can verify any message coming from the server. Simple. So the certificate authority generates a certificate by obtaining the user's public key by some trusted mechanism. Verify the user the really is who she says she is. Sign in using the certificate authority's public key, the user's public key, and the name. So these are the information, the 3 points I mentioned. So this allows two parties who have never met to establish trust between them to exchange certificates, do authentication using digital signatures. If, if they each trust the certificate authority that sign the other party, especially the server certificate, they can now be certain who the other party is, who the server is. So, so that's how this public key infrastructure is established and how it is uh, used to build the trust between parties. So this is an information about certificate. Okay. So this certificate is something like our identity card. So when you show your identity card to somebody, that person is going to trust your information because that identity card is signed or issued by a trusted party. So concept is similar to that. So here, I think I better show you a certificate. So first, what we do is in this kind of setup, first the client, the client or the person, the server, let's say the server needs to get a certificate from a trusted third party. So server gives creates a certificate sign-in request CSR, providing the information about the server. So that is done in the server's machine. So here in this information here, this is a certificate sign-in request generated in a server's machine. So according to this, this is generated by using a command. So this shows you, yeah, when I copy and paste that here, these are the information about the certificate sign-in request. The server certificate, uh, the server provides this information to obtain a certificate from a trusted third party. So common name, that is the name of the certificate, CHNI, an organization. I gave some fake information, FTV, locality RET, state S, country LK. So server provides this information and generates a certificate sign-in request, CSR. Once this certificate sign-in request is sent to the trusted third party will sign that certificate sign-in request and provide with a certificate. So for this CSR, the certificate sign-in request, the corresponding certificate came from the trusted third party is this thing. I'll copy and paste it here. And okay, so these are the information. The common name is like this: CHNI, organization FDB, locality RET, state is S, and LK is the country. So these are the information sent by uh, the server, and the trusted third party or the certificate authority says, okay, this certificate is valid from this date to this date, August 24th, 2020 to August 24th, 2021. This is the validity period. And issuer is the trusted third party. Issue of this certificate is this Serat Madhuvelthanna MMD Investments. He is the issuer. And serial number for this certificate is this. So this certificate is sent to the server from the trusted third party upon the request of the server using this certificate sign-in request. So server has to install that certificate in the server's machine. So when client communicates with the server, server shows that certificate to the client, and from that point onward, client has the trusted third party's public key, and this certificate is signed by the trusted third party. Because of that, the client can verify the signature in this certificate. Because of that, client is going to trust the certificate. So I will show that certificate in here. So this is, I'm going to open this, view certificate. So when we have the certificate, these are the information. So these are the country, state, locality, organization, common name, and these are the information provided by the server to the trusted third party. And issuer is this. Issuer is the trusted third party. Issuer's country is GB, state or province England, organization MMD Investments, organizational unit name, some information about that trusted third party, and serial number is given, and signature algorithm is SHA256 with RSA signature scheme, and this certificate is signed by the trusted third party, and also all the information about that signature and everything is, so here this is the fingerprints or the information about, like the details about the signature, and all other details are here. And once this is showed to the client can verify this certificate, because client knows the public key of the trusted third party, which is this party, Tidas Serat Madhuvelthan. Okay, I think it is clear to you. So this is like identity card. You can see all the information about the server, the name, uh, locality, and everything is given there. And the client is going to trust that information because client is trusting that trusted third party or the certificate authority. Okay, so because of that, uh, handshake protocol works, and both of the parties agree with the protocols to be used, and they authenticate each other, and then they perform kind of a uh, Diffie-Hellman key exchange, and then share a symmetric key for their data transmission, encryption of data in the data transmission. So this is about the handshake layer, handshake protocol. It provides one service for TLS connection, authentication, server to client. Ensure that the connection is really is with the server with the given domain name. Also establish keys that will be used in the record protocol for additional security services like data encryption. And this is a handshake example. First the client says, hello, here are the algorithm I know to use, and say I'm going to use these set of algorithms for my data communication with you. And server says, hello, okay, let's use the cipher suit you choose. Usually the server has a bigger range of cipher suits. Client has smaller set because client is a small machine, server is a big machine that can facilitate to many things. So upon the client's request, client's choice, server most of the time server uh, facilitates them. So then in this uh, first arrow you can see the client and server agrees to use certain set of algorithms for their communication. And then server sends, here's my certificate with RSA public key. Certificate is what I have shown you. Here's a Diffie-Hellman key exchange GX, and here's signature on my Diffie-Hellman public key to prove it's mine. So server shows the certificate, client can verify that certificate, and also server provides the Diffie-Hellman public key part. If you have followed that Diffie-Hellman key exchange or that discrete logarithm lectures, you can understand this easily. So Diffie-Hellman public key is computed and send that value to the uh, client, and also that value is signed by the server's sign-in key. Once it is received to the client can verify the certificate. Now client knows who the server is, and client will check the signature of this Diffie-Hellman public key part, and client computes its own Diffie-Hellman public key by choosing simple Y value and then send to the server. So server will generate the Diffie-Hellman. Server first verifies whether that Diffie-Hellman public key is coming from the exact client, and then server can compute the Diffie-Hellman shared value, and client can compute the Diffie-Hellman shared value, and then uh, they check the signature on public key is okay. So client will check that and compute the Diffie-Hellman shared value, and from that point onward, that shared value is used to do the uh, data encryption in the record layer. And this is how that Diffie-Hellman key exchange part works. That is continuation of my previous slide. And once the handshake is done at the 12th point, then the record layer starts. Then both the client and server exchange data in between them. They are encrypted by the symmetric key they generated, they computed based on this Diffie-Hellman algorithm. Okay, the TLS record layer that provides two services for the TLS connection: message confidentiality and message integrity. So in my previous slide, this in this diagram I have shown how the message authentication, that integrity and confidentiality is provided. Confidentiality is by encryption and integrity is by uh, message authentication code. Okay, so at this point I am stopping today's lecture. So from next week, from next lecture, we'll discuss some information further about this record layer operations. I think you can easily follow this when you have this set of slides and also some knowledge about the Diffie-Hellman key exchange and public key cryptography knowledge. Okay, thank you.